day, and welcome back to Tech Tips, Fixes and More. I'm Ron. Today we've got a consumer AV receiver. The owner of this thing brought it in, said that he was getting absolutely no sound out of it, and yet the power does come on and the display lights up on the front, but there's no sound whatsoever. I went online and I just basically put in a search on Google, and immediately I got hits on YouTube for a number of videos talking about this as a common problem, a known problem with these receivers, and not just this model, but some of the related models. The information in the video talked about a digital signal processing chip that has one of two problems. One is that sometimes the chip goes faulty and it seems to be a thermal problem. If you heat up the chip, the device will still start working correctly and may or may not continue to work correctly for a period of time. Sometimes when it cools down it quits right away. Other times, one person online said that they heated it up and it worked for 3 years. In that particular case, it may be the other problem that has been noted, and that is that these particular chips are surface mount chips with connections under the chip, and sometimes the solder joints go intermittent. And so when you heat them up, sometimes you will reflow the solder, and that will get it working, and it'll work indefinitely in that case. And there were two digital signal processing chips noted in these videos, but the one that most often is the problem is this one right here. Now, I noticed that this chip has a little sticker on it that says new, which I think is interesting in and of itself, because that may indicate that this device has been worked on before. Maybe that chip has been replaced before, because this is a known problem. So I'm probably going to heat this up, see if it starts working, and then let it cool down, see if it continues to work. And if it continues to work, I'll contact the customer and ask them if they want me to take this further. The videos I watched also indicated that these chips are not that easy to get anymore. One person that I watched online doing this heated it up to about 400 degrees Fahrenheit. And that same person also put solder flux around the chip, hoping that it would flow in and under and basically wet the solder joints under the chip. I'm going to have to turn this up a little higher. That seems like a lot of heat to put on that thing, and it's starting to even discolor a little bit. So at this point I had heated up that chip quite a lot, to the point where it was actually discolored around it. So maybe I heated it up too much, and I'd never gotten any sound out of the speakers, as had happened with some of these videos I watched. Also at this point I became aware how the system worked, that there were some displays on the front that indicated whether or not the speaker outputs actually were being connected, and they appeared to be on. So this would suggest that the chip was doing its job. So I decided at this point I better stop, back up, and take a closer look at the schematics and how this thing should work. As I started looking further and also looking online a little further, there was a couple of entries in there that talked about fuses in the lines for the output speaker relays. So there are relays that turn on, and they're turned on when that DSP starts working correctly. But those relays that connect the speakers also have fuses associated with them. So I started looking, and I found a couple of fuses here, and I'll show you where they are, and both those fuses were open. Here's my handy dandy fuse remover. These are the old style fuses. I think the size and style is GMA if I'm not mistaken, but anyways, this little end here allows you to pull these fuses out quite easily. So this is where they come from. I do have the power disconnected from this. I wouldn't be playing around in there with these fuses if I had the power still connected. And here's my trusty ohm meter. I've got it on the diode scale, which will beep when something's shorted and there's nothing. And you can actually see the filament is gone in that diode. Same with this one. So those fuses are bad. Now I have a collection of fuses that I've gathered up over the last, I'm going to guess, 40 years actually. Back in the 80s when I was doing repairs on an ongoing basis, I bought out another company that had a whole line of parts, especially in the automotive test equipment line, and I got a whole box full of these kinds of fuses, the cylindrical types. And so of course I went through here. I was sure I would have what I needed, and of course I didn't have quite what was needed. These fuses are 10 amp 250 volt fuses. I'm going to have to order fuses obviously, but I do want to test this and just see if it actually works. And so the closest I came was the correct physical dimensions, and they are 6 amp fuses, and I think for testing we may be able to use those and just see. And so we'll just see if that will blow the fuses immediately, and if so, then we've got more serious problems, but this will allow us to do a quick test. Oh. The relay clicked, and I think I saw a flash of light as the fuse blew. So we're going to check those fuses again. I'm pretty sure they blew. So both of those fuses blew. So now the question becomes, did I cause this problem? Did heating up that chip somehow cause me to blow these fuses, or is there something else going on in the output on this thing? I may need to, from here, look for a schematic and see if I can figure out what's going on with the relays and those fuses, and I will double check to make sure I haven't inadvertently shorted something out on the output. Okay, so I did manage to find a schematic, actually many schematics for this AV receiver. I found a manual that's 72 pages long, and about half of that or more are pages of schematics, so there's a lot of detail there. And I was able to kind of trace through some things and make some progress on understanding a little bit more about the situation. I'm going to put up part of the schematic here right now, and it's the schematic for the power supply. On this schematic, I've circled the key components that I want to talk about right now. In the left-hand corner, I've circled the transformer. Okay, so there's a fairly good-sized transformer in there that is providing the power for this device, and from there it goes through some connectors, and it goes through the fuses that I replaced. You can see them, F6901 and F6902. So those were the ones that were replaced. From there, the AC power from the transformer goes into some relays, and there's actually 4 relays there. The way this circuit works is that there is power on to a power supply circuit that isn't shown in this particular graphic, that provides startup power, or power that allows the display to come on, but the speaker outputs are not working. And then from there, that AC power goes to the next set of relays, and those ones are delayed so that the power doesn't come on until after a period of time, so that you don't get a big thump in the speakers. From there, it goes into a bridge rectifier, and that is filtered, and it provides plus minus 54 volts. So when everything is working right, there's plus minus 54 volts. So after getting this schematic, I tried to isolate things to find out what was blowing these fuses. I removed the couple of the relays so that that would disconnect everything down the line. I believe the 2 that I removed were the second set, so that the power couldn't get to the actual output circuitry, which is the amplifiers. And the fuses did not blow, and so I knew something further on in the circuit was shorted out and was causing the problem. And I put back in these relays. I checked the bridge rectifier just to make sure that it wasn't faulty, and then I proceeded to disconnect components down the line until I isolated one of the audio amplifier chip. And when I removed the 3-channel chip, there's 2 2-channel chips and 1 3-channel chip. When I removed the 3-channel chip, the fuses were no longer blowing, and so I knew that it had to be that chip, and that's when I ordered actually all 3 chips, so that I could replace at least the one and proceed from there. And there's quite a number of connections. I can tell already that these pins are a little oxidized. So once I had the audio amplifier soldered in, I needed to power the circuit up. And I wanted to bring it up slowly, so I used a variac to bring on the AC voltage from the line slowly. And I did that, and everything was fine. I didn't blow any more fuses. Did some testing, and it was clear that replacing the audio amp chip had solved the shorted power supply problem, which was causing the fuses to blow. I did have some other issues that came up, and they were really caused by me in the process of working on the thing. A ribbon cable came disconnected, and it took me a little while to sort that out and find out why things weren't working. Once I tracked that down, reconnected the ribbon cable, I made some progress. But in the end, I still was not getting any sound to the speakers. And it appeared
There's a mute circuit in there that is muting the audio signal that's being sent to the amplifiers. And it's a little difficult to tell where that mute circuit or that mute signal originates. I think it originates in the DSP chip that I was talking about before, and that is this chip right here.
So at this point, I'd pretty much come full circle. I had found some problems, I'd fixed some problems, but at this point I was coming back to the point where it looked like the DSP chip that I started with was probably not putting out the correct mute signal to, or unmute signal, if you will, to allow the speakers to work. And there was a question of how much time to spend on this and how many parts to put into it. So I guess this was a bit of a Hail Mary move here, but what I decided to do was to go back and remove that chip just in case the connections underneath it were not being soldered or were not connecting properly. So I removed the chip and proceeded to clean it up. Okay, this may be a case of the operation was a success, but the patient died. As you can see, in lifting this thing, I don't know if I didn't get the heat even enough, but it looks like one of the pads for the ball grid array has lifted here. And I have my doubts whether I'm going to be able to repair that. I'm going to try, but I'd be really surprised if there's any way of fixing that. That was one of 256 connections to that chip. I later traced that particular connection in this schematic back to that mute or enable line. So I did try to repair that connection on the BGA. I moved the pad back into place, checked to make sure that it was actually connected in the circuit where it was supposed to go to, which was quite surprising in itself, but it was. And I soldered the BGA chip back in. And that was a bit of a process. I hadn't done that before, but I did the best I could with the equipment I had. And in the end, it did not work. So it's difficult to say whether that was the original problem or the BGA chip was the original problem or what, but there was no way of determining for sure. And in the end, I had to contact the customer and basically tell him this thing cannot be fixed. This was a bit of a long, painful process and disappointing, because you never like to tell the customer that you cannot fix the equipment that they've sent to you. It's always hard to know whether or not there was something different that I could have done, but give it my best shot. And in the end, the customer, I guess, will have to replace the receiver, because really there was nothing functional on it in the end that could be used. So, disappointing, but I learned a number of things from this, and hopefully there's something in there for you that you may find interesting or useful in the future. Nobody wants to admit that they failed to fix something, but it happens. And you have to go on and try and do the best you can the next time. So I guess that's it for this one. Thanks for tuning in. Thanks for any comments you might have. I appreciate a like if you can do that. And we're going to wrap it up with that, and we'll see you on the next one.